Okay, moving on to example 2, graphing with polar coordinates. Graph all the points in a plane that satisfy the given polar equation. So r equals 2. Remember, I'm defining this to be 2 units away. But if we need all the points that are 2 units away, that would actually be, remember the definition of a circle. All points in a coordinate plane that are 2 units away from center. I'd be able to get a better circle there. Hold that. I don't seem to be getting the true circle drawn with my new Apple Pencil. That's alright. Roughly that. And then for B, for r equals -2, that would be, remember, if we consider this to be 2 units away, if we're talking about the angle of 0, then this is 1, then that's 0, then this is -1 and -2. So starting at an angle of 0, this is r equals -2. If we move to then an angle of pi over 2, then r of -2 would be down here. And then if we move over to theta, r of -2 would be here. And hopefully you're kind of getting the idea. If I move to 3 pi over 2, r of -2 would be up here. So it actually just, once again, give me a circle of radius 2. So it doesn't matter whether r is positive or negative, it will give you a circle of that radius, the absolute value at least of r. And what about theta equals a number? Well, theta equals pi over 6. This would be 1 comma pi over 6. This will be 2 comma pi over 6. This would be 3 comma pi over 6, 4 comma pi over 6, 0 comma pi over 6 will be there, and then -1 comma pi over 6. If you're getting the idea here, in fact, make a straight line. Okay. So then, for example 3, I'd like you to take a look at what these graphs look like on the graphing calculator. It would be a good time to pause your video, take a look at them in the graphing calculator, and then see what you see when you check them out. So let's pause this video. Okay, so hopefully you're now resuming after having looked at some, if not maybe one of these in the calculator. Now, one of the things I would do if I was graphing this without a calculator, which makes it a little tricky, but sine of 6 pi, if I start at, say, theta equals 0, I get 0. But then if I go up to, as theta increases, so say for instance theta is pi over 6, then actually at pi over 6, at this place right here, and I'm going to consider this to be 1 unit just so I get a nice wide graph here. So I start with when theta is 0, I get a radius of 0. Then when I get to theta equals pi, I get sine of 6 pi, which is then 0. So I look at some, when theta equals pi over 6, excuse me, I get to sine of pi, which is 0. So then actually I want to go to maybe pi over 12 and see what happens there. At pi over 12, I get sine of pi over 6, which is, I get sine of pi over 2, which is then 1. So what actually happens is we go out to 1 and then we come back to 0. So this may look familiar to you, and that what you saw in the calculator was a rose curve, if you will. And if I continue out in this range between pi over 6 and pi over 3, what I'm going to see is a similar fashion, but I'm actually going to get negative values in here, taking me out to 3 pi over 12, which then gives me 3 pi over 2, which is a -1. So down here I get a -1. So I actually get something that looks like this. Brings me back here. And then as I go in this range from pi over 3 out to pi over 2, what's going to happen here is we're going to get this similar fashion. We're going to get this thing going out. And hopefully then you saw this in your calculator, and you maybe also are noticing then some trends of what happens with this thing. So this is what happens in here as we go between here and here, and then it starts working its way back. Notice it's kind of like skipping over every range, but then when it comes back, it'll go into those places and make those petals, if you will. So now I'm going from here to pi, and that's going to make one in the reverse direction. So this is what's happening in your calculator as it's making this thing, and it starts working its way over here and back, and then over to this direction, fills it in, and comes back over here, works its way in here, fills that one in, and then works over here, fills that one in, and then down here, fills that one in, and then over here, fills this one in, and then over here, fills that one in. I think I got the right ones, I got all of them there. So you'll notice if you count them up, there are actually, and this was like a rule for you last year, 12 petals. And each petal actually happens from 0 to pi over 6 is the first one, and then kind of works its way from there. And so then for B, 1 minus 2 cosine theta, if theta equals 0, then we have 1 minus 2 times 1, so we have negative 1. So at theta equals 0, I'm going to make this actually 1, 2, 3, 4. So as theta equals 0, r equals negative 1. And then as theta works its way up here, like say pi over 2, I get 1 minus, so cosine of pi over 2 is 0, so then I get 1. So then the question is, what's happening in between those places? So in between those, from 0 to pi over 2, what's going on with this thing? Well, if I get to a place where cosine equals 1/2, which is namely at pi over 3, that's when I get cosine equals 1/2, so then I actually get an r value of 0. So it'll be here when I get back to an r value of 0, but what's happening in between? Well, I have a negative r value. I'm going to work my way to 0, and then it kind of builds its way around here. Now what happens after pi over 2? Let's say, taking it all the way out to a value like pi, then I actually get a value of 3 when I'm out there. So 1, 2, 3. So what happens is this thing takes itself out to here. So this is what happened in the original part of it. And then the question is, what will happen after from here? And actually what happens after is we get a symmetric looking graph, and this graph works its way around to, I'm going to do that. Working its way into 0 here, and then filling that in. And so you may remember a name for this last year, not necessarily important, but the fact is it's got that inner loop there, which is important. And then for C, r equals 4 sine theta. At theta equals 0, we get 0. But then if I work my way up to pi over 2, actually start at pi over 6, that would then be value of 2. And then what happens when I get up to pi over 2? At pi over 2, I get 4. I'm all the way up here. And what happens if I get out to pi? I get back to, so sine of pi is 0. I get back to 0. So what actually happens then is this makes a circle. That's what you saw in your calculator for that, oddly enough. Okay, I think